All right, so we're going to talk about the polar form of complex numbers. This is going to be super brand new to you. In Tennessee, they had changed the standards for things you can learn about complex numbers. And so, one thing you didn't learn in Algebra 2 that you used to, it doesn't matter, is how you plot a complex number. And so, we learned that there's the regular Cartesian coordinate plane, the rectangular coordinate plane. We learned there's the polar coordinate plane. There is another one that is called the complex coordinate plane. And on the complex coordinate plane, the horizontal axis is called the real axis. And the vertical axis is the imaginary axis. And a complex number is like this one right here, 3 plus 2i. 3 is called the real part, and you did learn this. And 2i is called the imaginary part. And so if you were going to graph that point on the complex plane, you graph it just like an ordered pair. The real part is how many you move horizontally, and the imaginary part is how many you would move vertically. So that point graphs the same as the point 3, 2. So that is the complex number 3 plus 2i. That doesn't come up very often in anything that I teach. There is a lot of math that I don't teach. Complex numbers are used in extremely complicated problems where you're trying to solve something inside of a black hole. Now, some of you may become a rocket scientist and need to use complex numbers. I don't know. There's a good chance somebody in here might be. But for what we do in calculus and what we do in pre-calculus, we don't use complex numbers to the extent that they are used by people in their real jobs. But the only thing we're going to do today is change a complex number from its rectangular form, which could either look like this or as an ordered pair, to polar form, and vice versa. So we're going to use the same rules we did yesterday to do what we're doing today. All right. The thing that's a little different is our final answer is going to be written like this. So you're going to go from something that's like a plus bi to this form right here, where a is found by doing r times the cosine of theta. This I is the same I. And b is found by doing r sine of theta, which is exactly what we did yesterday to get x and y. Okay, so let's do it. I just said a bunch of words. It's fine. You're going to be fine. All right, so a complex number is represented by a point in the complex plane. The complex number has rectangular coordinates, -2, -2. So just like yesterday, I would start off by just doing a little graph of the point. That's going to come in handy later. So if it was the complex number, it would be -2 minus 2i. But it plots exactly to the same place as the point -2, -2. All right, so what we want to find is r and theta. What we have is x and y. So those of you that were here yesterday know that to find r, you're going to do the square root of x squared plus y squared, or basically the Pythagorean theorem. All right, so I'm going to go ahead and just square -2 and get 4. Square -2 again, because that is our x and our y. And we get that r is the square root of 8, or in simplified form, 2 square root of 2. All right. The other thing we have to find is the angle. All right, and when we're looking for the angle, you have x and y, and you want to find theta. The tangent of theta is equal to y over x. Now, out of all the things that we learned about this yesterday, this is the most difficult to get right, I think. It's figuring out theta, because there's just a lot to think about. So in this case, I would put -2 over -2. The tangent of theta is 1. All right, so there's only one of the special angles, like out of the original pi over 6, pi over 4, and pi over 3, that the slope at that angle is either 1 or negative 1. Which one is that? Pi over 6, pi over 4, pi over 3. Pi over 4. And so I know, if I know the tangent of theta is 1, it's going to be one of those pi over 4 angles. Well, how do you decide which one? Because there's 4 of them on your unit. Right, we're looking at the one that's in the correct quadrant. And pi over 4 in quadrant 3 is 5 pi over 4. Oh, you guys might want to grab your unit circles out unless you have that permanently in your brain. You have to use the unit circle quite a bit on these lessons. Okay, so we have found our R and we have found our theta. And what we did yesterday, we would just write that as an ordered pair with the R and then the theta. Today, we're going to write it like this. All right, so we would start off with our R, which is 2 square root of 2 cosine of theta plus I, and then our R again, sine of theta. All right, so what we just found was the polar form of the imaginary or the complex number negative 2 minus 2i. They are the exact same number, just written in different forms. Okay, so now we're going to do it the other way. We're going to have it in polar form and we're going to write it in rectangular form. All right, so number 7, we have this number in polar form. So what is R? 4. And what's theta? 7 pi over 6. All right. And so all we did was just took this generic and pulled out the R and pulled out the theta. All right. So when we have R and theta, we can find X and Y using the formulas we talked about yesterday. But if you weren't here, X is found by doing R times the cosine of theta. So that's going to be 4 times the cosine of 7 pi over 6. All right, and this is where you would want to use your unit circle. So you would go to the angle 7 pi over 6. And if we want to find the cosine, which coordinate are we going to use? The x. And so that if we look at 7 pi over 6, the x coordinate is going to be negative square root of 3 over 2. So x is negative 2 square root of 3. All right. And then for y, when we have r and theta and we want to find y, we do r times the sine of theta. Right, so then we would still look at the unit circle. We go to 7 pi over 6 for the sine. We would use the y coordinate, which is negative 1/2. So in this case, y is negative 2. Okay, so if it asks you to write the complex number, the actual complex number is negative 2 square root of 3 minus 2i. That is not what they asked you to do in the directions, so we're going to follow the directions. They want you to write it using rectangular coordinates, just x comma y. So that is what they're asking you to find. All right, what questions do you guys have?